Hello everyone, my name is Leah Kopke. I'm a 3D motion design freelancer, and this is my podcast, Ambient 3D Animations. I'm really excited to cover the topic of shredding when it comes to pyro simulations. I haven't really seen anyone yet try talking about this on YouTube personally, so I'm excited to be talking about it here today with all of you. Shredding is an extra force inside of a simulation scene for Pyro, and this allows you to sharpen the look of your flames and your smoke inside of your pyro simulations using repulsion and attractive forces inside of Cinema 4D. So let's go ahead and talk about this. I'm really excited to cover this topic here today. So here we are inside of Cinema 4D. I'm just going to break down really quick how I set up this scene so that you are aware of what settings I'm starting off with inside of here. I have 3 spheres in here. They all have a pyro emitter tag applied to them. So if I press play, you can see we have some pyro simulations happening. This one here on the right looks a little bit different. And we've talked before about the draw settings inside of the simulation scene object or your project settings tab. I'll leave links to the episodes covering the simulation scene as well as covering the draw settings and the pyro output as well as the pyro emitter tag, so that if you want to learn more about those topics, you can. Since I've already covered those, I'm going to be talking in a way assuming that you know those subjects since we've covered them before. But inside of the simulation scene here, you could see that you have this draw option to control the look of your pyro simulation. So I'm in the simulation scene under pyro, and here I just have the shaded option for this first sphere over here. I also have that for the second sphere over here. For the third sphere, in the settings controlling that one, I have this simulation scene controlling it, and I used temperature. So that is visualizing the temperature of our simulation rather than showing a shaded version of it. So I'll change this back to temperature, and it's showing those values for the temperature as a gradient so that you can see the hotter areas of the fire and the cooler areas of the fire, because we're going to be talking a little bit about how this affects the temperature. So it's nice to visualize it. Now, another interesting thing that I did in order to make this easy to visualize is I turned off the noise setting for these. So in here at the bottom where it says noise, I just disabled this. This is not checked on for any of these fires. This one here on the left is just basically the default settings with the noise turned off so that you have a basis to compare the changes we're going to make to the second sphere. So this is your example that's a consistent reference throughout us messing around with the settings so that you can compare and contrast the default with the changes we make. And so that's pretty much how this scene was made. The one interesting thing that I did to make this easier to visualize is inside of the extra forces where we scroll down, you'll see our shredding options here. Now, I had right-clicked on all of these and used a set driver expression to control these settings. Basically, what I did is I had each one of these settings in this simulation scene drive the settings for this other one with the temperature. So that way we can actually preview the same settings for the shredding, both as this shaded draw style and the temperature draw style, because I thought that might help you see it. We're going to talk about this a little bit more. So something really important to keep in mind is that shredding is setting your repulsion and attraction forces to help define and sharpen your flames, or your density for that matter, in your pyro simulation. And you need to choose a source for these repulsion and attraction type forces. So right now our source is set to temperature. You can choose density or fuel as well. So that's our source. And your push strength, that is controlling your repulsion force. The pull strength is controlling your attraction force. Your maximum magnitude, that is controlling your limit for how strong those forces can be. And your source threshold, that is controlling the balance between them. So I want to talk about this a little bit more in depth. But before I do that, I just want to start this over at the beginning, and we're going to be moving around some of these settings so that you get to visualize it a little bit. And then we're going to break down these concepts a little bit more. So I'll hit play. And you can see this is what it looks like at the default. Now I'm going to increase this push strength. And again, that's our repulsion type forces here. And you can start to see that these are starting to push apart, and it's starting to look a little bit different. You can especially see that when we have this preview of the temperature over here on the right. It's still affecting this over here, but it's easier to see the temperature on this side. So you can especially see it right there at the beginning. If you compare this one without any adjustments to it over here on the left, and this one that has these settings adjusting it, I'll start at the beginning. Look at that difference. Like right there, you can see this is really spreading out. Those flames are pushing away from each other. That repulsion strength, you can see. You can especially see it over here. So that gives you an idea of what this is actually doing here. And then you also have the pull strength. So I'm going to right click on this left arrow here because that sets it back to the default. And let's mess around with the pull strength a little bit. I'm going to press play. I'm going to increase this value over here. And you can see that this fire is starting to look actually a little bit smaller than this one visually. And that's because it has those attraction forces pulling in those flames a little bit closer. And you can, of course, use a combination of these two. So I'm just going to pick different values for these two. And the interesting about the push strength is that the higher you increase the push strength, that also tends to help the flame separate or cool quicker. So you actually end up getting more density when you do that. Like you can see that when I increase the push strength, we get a little bit more density or smoke showing up in our simulation. So this is a nice way to sharpen your flames and just get that added extra detail in there. You can, of course, also decrease the voxel size. If you decrease the voxel size, that'll, in a way, increase the resolution of your fire. It'll also make it so that it takes a little bit longer to calculate. So you got to be careful of that and how much memory your computer has, as well as how much time it'll take. But it's good to be aware of that option is there. So I've changed all of these to have a voxel size of about 3, just so that we get a little bit more detail in here when we're previewing these. And we had mentioned how you can also adjust the source threshold. So I'm going to move this, and actually the higher that I increase this source threshold, the more the repulsion type forces will appear in the simulation. And if I decrease it, those attractive forces will be stronger. So let's talk about this a little bit. So I took some notes to make it a little bit easier. So shredding is an extra force setting used to control the additional attraction and repulsion forces in a pyro simulation in order to sharpen flames and smoke. Your source can be chosen. We talked about that. Right now we're showing temperature, but you could also use density, use these attraction and repulsion forces to control the density or the fuel. It's most noticeable for the temperature or the density because these are present throughout the entire simulation, whereas fuel for an explosion, it may be used up in the beginning and then no longer be available. So it may not be as noticeable with the fuel option as with the density and the temperature. You can think of density as the smoke in the clouds. The temperature you can think of as the flames. We talked about how the push strength is the repulsion force, so the flames being pushed apart, or the density being pushed apart to disperse. You also have the pull strength, that's the attraction force, so that would pull those flames in closer. That's when we saw the fire become a little bit smaller because of those attraction forces when we increased that. The source threshold is used to create a balance between the attractive and repulsive forces. And this one can be a little bit harder to remember, so I thought it would help to show this here. When the source property is greater than the source threshold value, the repulsion forces increase. When the source property is less than the source threshold value, then the attraction forces increase. Your maximum magnitude is an upper limit you can choose to prevent your attraction or repulsion forces from scaling to too high of a number that just doesn't look right to you. So those are good to be aware of. There's another hidden option here in these settings. So let's talk about those a little bit. You'll see that this push strength and the pull strength have these options below them. If we click on these little arrows here, we have the push range and the pull range. And these are basically setting limits for the strengths. So the push range sets a limit to the push strength. The pull range sets a limit for the pull strength. So inside of the manual, it does supply a couple formulas for these and how they're calculated. I don't think you need to memorize them or even know them or remember them, but I put them in here for anyone who is a little bit of a nerd and is curious, because I'm a very curious person. I want to make sure that I leave it there for those who are interested. The absolute value of the source threshold minus the source property value divided by the push range value is how this is calculated for the push range. That's how it sets a limit on the push strength, that repulsion force. You also have the pull range, and you'll notice that this formula looks very, very similar to the push range. The only difference really is that the push range value is replaced with the pull range value, and this one is focused on attraction forces. The higher the push range value means less push strength or repulsion force. The higher the pull range value means less pull strength or attraction force. So that's what there is to remember. I think it's a little bit easier when we visualize this, so I'm going to go ahead and we'll take a look at these settings inside of here. So I'm just going to set these back to the default here for a moment. And I'll start this back at the beginning. So let's increase the push strength. I'll increase the push strength all the way. So right now it's at 15. I can even increase it further than that just to make this a little bit more dramatic of something to see. Let's try 30 and see how that looks. Or try increasing this maximum magnitude. Okay, so start this back at the beginning. You can see that as I increase the push range, the less strong those repulsion forces are, the further I increase this. I'll actually set this to the highest amount and start at the beginning for you to compare this against it, the push range set at 0. So when the push range is set to 0, the effect of the repulsion force is being applied to the entire fire, and the push range is limiting it by the temperature in different parts of the fire, because we have our source as the temperature. If we set this to density, then it would be using the value of the density instead. Or if we had this set to fuel, it would be using the value of the fuel. So let's have this start at the beginning. So this is with the maxed out push range. We'll go ahead and press play. So you can see that there's a little bit less push range there as to when, or a little bit less push strength there with the higher push range, and I'm going to reduce it to 0, and you'll see that push strength is now applied to the entire fire regardless of the temperature values throughout it, and I'll press play. Now you can see it's spreading out a whole lot more. You can see that change there. So it's good to be aware of these, and it just helps you adjust how your flames look within the simulation. So I wanted to show this. I did adjust these settings for when I created the wood burning stove for the library we 3D modeled, and I want to make sure to cover those for all of you who are interested in this topic. What I'll cover next is how to render out your pyro simulation in terms of creating the material for a volume shader. And once we finish up that and wrap up that, I'm really excited to get into generators with all of you. So I hope you stay tuned for that as well.